Hi everyone. Let us look problems on uh, some of polar curves. That is the topic. Um, let us see what is this all about. So we have is we have x and y. Okay, x and y uh, axis. We have x and y axis in which if I try to draw a line from here, okay, somewhere around here, okay. If I consider this as r, and this is the point where r comma theta, okay, along this is so which makes an angle which is theta. So here we have x and y, which is on Cartesian coordinates for the point uh, which is x comma y, and points which is x comma y. Okay, so we have r is equal to square root of x square plus y square, and uh, we have x is equal to r cos theta and y is equal to r sin theta. So, which is uh, theta would be tan inverse of, okay. So that's that. So let us look the problems related to this and find the angle between the curve which is given to you. Okay, so let us try to solve those kind of problems. Okay, now the problem, let us do the first problem on this and try to understand the concepts. Okay, okay. uh, Let me try to solve these problems, and let us find the angle which is phi. Okay, angle which is phi for the polar curve. For the polar curve, which is r is equal to, we have that as a times 1 plus sin theta curve, which is pi by 2. Okay, so this is the problem. Now, since we have been given r as a times that of 1 plus cos theta, so now let us differentiate this with respect to theta. So when you differentiate r with respect to theta, this becomes dr by d theta. Okay, dr by d theta. So a cos theta, I get a cos theta. Therefore, tan phi, tan phi, which is equal to r times d theta by dr. Yeah. So let us substitute those. So uh, we know what is r and what is d. We have r and as well as this. Let us substitute it. So when I substitute this, I get a times 1 plus sin theta. This will be a times cos theta. Okay. Now, since a and a gets cancelled, so I'll be left with 1 plus sine theta, and in the denominator I have cos theta. So 1 can be written as cos square theta by 2 plus sine square theta by 2. Okay, and again sine theta can be written as 2 sine theta by 2 cos theta by 2. Now this divides by, again I can write this as cos square theta by 2 minus sine square theta by 2. This I have as cos theta by 2 plus sine theta by 2 whole square, and this is cos theta by 2 uh, plus sine theta by 2, and sine cos theta by 2 minus sine theta by 2. So 1 gets cancelled. One of the term plus sign gets cancelled. So I'll be left with cos theta by 2 plus sine theta by 2 divided by cos theta by 2 minus sine theta by 2. Okay, this I can further simplify that as divided by 1 minus tan theta by 2. Now that can be written as tan of pi by 4 plus theta by 2. Okay, now this is tan phi, so I need phi, okay, which is pi by 4 plus theta by 2. uh, Now theta being with respect to pi by 2, so at theta as pi by 2 for tan pi by 2, if you substitute it as tan psi as some as tan pi by 4 plus 3 pi by 4. Okay, so which this slope when theta as theta which is given as pi by 2, okay, is 0, tan psi is 0. Let us look into some of the other problems. Okay, now the angle between the polar, let us try to, but we have been given as the two polar curves, so you have to find the angle between those two curves. Okay, that's quite interesting, and let us try to solve those kind of problems. Okay, suppose if I have to find the angle uh, of intersection of for each of the following pairs of polar curves. So I have been given as r is equal to 2 sine theta and r is equal to sine theta plus cos theta. So let us find the angle between. So let me consider first, which is r is equal to 2 sine theta. So now differentiating with respect to theta, I get dr by d theta. Okay, so this is 2 cos theta. Again, I have tan, if I consider this as phi 1 corresponding to that. So this is r d theta by dr. So we have previously used this formula. So this would be r being 2 sine theta, and this is 2 cos theta. So I get tan theta. So when you look at this here, tan, you have tan phi 1, and phi 1 would be theta here. So this is for this. Okay, let us look at r is equal to sine theta plus cos theta now. differentiating with respect to theta. So here dr by d theta, okay, dr by d theta, and this would be cos theta minus sin theta. Again, if I consider as tan phi 1 when is taken, so this is r d theta by dr. So this should be this is sine theta plus cos theta, and this is uh, cos theta minus sine theta. Now, if I try to simplify this further, I get 1 plus tan theta, and this is 1 minus tan theta. Now, we know this as tan of pi by 4 plus theta. Okay? Now, this phi 2 would be pi by 4 plus theta. Now, the angle between these two curves, okay, so that would be phi 1 minus phi 2, okay, and it is mod of that. So, I get pi by 4. So, the angle will be pi by 4. Again, again, I have to find the angle between the curves, which is given. Same process. Let us see uh, those types of problems now, since you are familiar with those problems. Now, r is equal to a times 1 minus cos theta. I have another curve which is r is equal to 2a cos theta. Let me try to solve this. Again, the process again here with respect to theta. So that would be dr by d theta. Differentiating with respect to theta, I get a sine theta. Okay, and again tan phi 1 will be r d theta by dr. That would be a into 1 minus cos theta, and this is a sine theta. So if I try to simplify this further, I get here as 2 sine square theta by 2, okay, and in the denominator I'll get 2 sine theta by 2 and cos theta by 2. 2 gets cancelled and one term of sine gets cancelled, so I'll be left with only tan theta by 2, so which is tan phi 1. So phi 1 would be theta by 2. So likewise, let us next one, next curve which we have, that is dr by d. So this will be minus 2a sine theta. Okay, so again tan phi 2 is r times d theta by dr. So this would be 2a cos theta by minus 2a sine theta. So cot theta. Now which can be written as tan of pi by 2 plus theta. Okay, now I need phi 2, so that would be pi by 2 theta. Now we have mod of phi 1 minus phi 2, uh, which would be, if I try to simplify, pi by 2 plus theta by 2. Now further, if I try to solve this, okay. Now the point of intersection, which is for I keep this result as one, something like that. So now the point of intersection of the given curve, which is and we have r is equal to a cos theta, 2a cos theta. Points we can get as cos theta as 1 by 3 here. Okay, so the theta would be cos inverse of by 3. So that is that. So the angle which is theta, which is given here, we get this as pi by 2 angle between the the two curves. Okay, and also the angle between these curves, which are evidently obtuse, the acute angle of that is uh, this would be the acute angle. That's that. So which is half times that of cos inverse 1 by 3. Okay. Let me try to explain another problem, which is quite interesting also. So also it has been very important. Okay. So let me try to solve this. Okay. Again, you have to take in those two curves. Okay. So so let me write down the curve. R is equal to a log theta. Okay. And another curve I have R as a by log theta. Okay. Now this dr by d theta would be a by theta. Log x will be 1 by x, so it is theta. So uh, it is 1 by theta. Okay. Now, so which is equal to if I take this as a log theta, this is a by theta. So I'll get theta log theta. Okay. This is for phi 1, tan phi 1. Okay. Let me look into the next part here, which I have this. So this would be dr by d theta differentiating with respect to theta. So this is minus a by log theta whole square. Okay, and the differentiation 1 by theta here. Okay, that. Okay, let us further continue to solve this. So again here tan phi 2 is r d theta by dr. So if I try to simplify this, overall I get as minus theta log theta. Okay. Now tan phi 1 tan phi 2 mod of this is tan phi 1 divided by 1 plus tan phi 1 tan phi 2. So this would be when you try to simplify this, I get 2 times theta log theta divided by 1 minus theta square, and this is log theta whole square. And now if I look back again, r as I have a log theta and r as a by, if I put that a log theta, which is equal to a by log theta. Okay, so I get log theta whole square, which is equal to 1, or theta is equal to, that's what I get. For the previous problem, I've done the same thing. So let us substitute that. So tan, um, I mean, if I put this together, so it is, this is tan minus phi 2. Okay. So tan phi 1 phi 2. Okay. So this is 2e by 1 minus e square. So I need phi 1 phi 2 would be tan inverse of 2e by 1 minus e square. So this is this. Let me move on to the next problem. Okay. Again, the polar curves will be given. So we have to find the angle between that and so on. Um, Now let us prove that these polar curves intersect orthogonally. Let's try to prove. So r is equal to a times that of 1 plus cos theta. Okay, and we have r as b times that of 1 minus cos theta. Let us prove that these two curves intersect orthogonally. So again, this is dr by d theta. So this is minus a sine theta. Okay. So tan phi 1 is equal to r d theta by dr. So let us substitute it. So you got a 1 plus cos theta. This further, or else let when you try to find what is tan phi 2. Okay, so dr by d theta. So this would be b sine theta. Okay, so I get this as this is d theta by dr, and 1 minus cos theta, and this is, so you can cancel this and this. Now let us take tan phi 1 tan phi 2. Okay, so this would be 1 minus cos square theta plus and minus, so cos square theta, and this would be minus sin square theta. So you had minus, so which results to minus 1. Therefore, this intersects orthogonally. So hence we have proved that this intersects orthogonally. So thank you for listening, and we'll come back again. Please tune in to